And if you notice, the difference here is our top number is not a number. It's an infinity sign, which means that you never stop. So the way that you would write the sum of an infinite series, like you just write infinity on top, but it just means it just keeps going forever. Which wouldn't be very much fun to add up, right? So we got two things to focus on today. One is, sometimes they give you an infinite series, but they only want you to find part of it, and they call that a partial sum. So the partial sum of an infinite series means you don't have to add up to infinity. And so part of your homework today kind of looks like this. I try not to put 4 dots, but I do sometimes. That's not true, but there's no point arguing with you because you argue everything except. I used to put lots and lots of dots because I like lots of dots. But then senior English people informed me that you can only have 3 dots and you cannot have any more dots. So I used to have stuff that had like 10 dots on it, and I've gone back and revised them. But there are still a few of these that I get a little heavy with the space bar or the dot, and I put too many of them. I'll just be so happy. Find the fifth partial sum. I just want you to make sure you understand what this means, because some people see this on a test and they think, oh my gosh, how am I supposed to add up to infinity? But you don't have to. It's telling you where to stop. It's basically saying you only want the first 5 terms of this infinite series, so you're going to do it exactly like we did yesterday. You're just going to stop at whatever partial sum it tells you to stop at. So I'm just going to go not from 1 to infinity, I'm just going to go from 1 to 5. So to find the fifth partial sum, I'm just going to take the first 5 terms. 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. This does go on forever, but they don't ask me to find that sum. They ask me to just find the partial sum. I think you can. You know, when you go to Purdue, they don't let you use calculators. I think that's 55. Because 9 plus 16 is 25, plus 25 is 50, plus 5 is 55. That's not so bad, yes? Partial sum. It's just kind of one more little vocab thing. That's good. But I'm just saying, I don't think they like calculators ever. They're anti-calculator. What about this one? What if I said find the sum of this? Find the sum from 1 to infinity of 1/10 to the n power. Yes. Can you just not talk anymore, Taylor? This one does not say where to stop, which means they want you to tell me what is the sum if I keep going forever and never stop. And it seems like a contradiction. Like, how can you tell me the sum if I never stop? I want us to just look to see what happens. What if I plug 1 in there? What do I get? 1/10 plus. What if I plug 2 in there? Yeah, 1/10 squared, or just 100. Plus, what if I plug 3 in there? 1/1000. Pick 10 since it's not so bad to do powers of 10. powers of 7, I don't really know that many of those, but we could do the same thing. If I went the next one, 4th power, I just add another 0. This would be 1 over 10,000, and I'm just going to put plus dot, 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 dot. Let's change these to decimals, because I feel like it's easier to add them up, so we have to get a common denominator. What is 1/10 as a decimal? 0.1, right? Like, or 0.10. That's why it's so nice to do tenths, because the way you say it is a decimal. 1/10 is 0.10, or 0.1. Plus, what's 1/100th as a decimal? 0.01. Plus, what's 1 over 1,000, or 1/1000? 0.001. See what's happening here? 10,000th is 1.0001 plus dot, dot, dot. So I'm going to keep getting terms there. What am I going to get when I add all that up? I add 0.1 to 0.01. Do you agree that that's 0.11? You line up the decimals. And then another 1 on the end of that. And then another 1 on the end of that. And am I always just going to keep adding another 1 to the end of that with every term? Which means I end up getting like 0.1111111. Or how do we usually write that? Can we say like 0.1 repeating? Which means, can I say with 100% certainty that I know the sum of this by only adding up the first 4 terms? Yeah, which is kind of a cool thing, because you wouldn't think you can add up something to infinity. We actually could even write this as a fraction. Most people don't know these, but do you know what 0.1 repeating is as a fraction? Think about other repeating things that you know. What's another repeating decimal that you know as a fraction? 1/3, right? 1/3 is 0.3 repeating. If you write this as ninths, what would this be as ninths? 1/3 is what ninths? 3/9? What's another repeating decimal that you know? You should know 0.6 repeating. You know what fraction gives you 0.6 repeating? Not 1/3, it's... And what would 2/3 be as ninths? 6/9? So guess what? Every ninth fraction is a repeating decimal, and it's always whatever the top number is. So 3/9 is 0.3 repeating, 6/9 is 0.6 repeating, so what fraction is going to give me 0.1 repeating? 1/9. And if you check on your calculator, 1 divided by 9 is 0.1 repeating. 7/9 is 0.7 repeating. 8/9 is 0.8 repeating. 9/9 you'd think should be 0.9 repeating, but it's just 1. That's 0.9 repeating, and it just goes to 1. Well, obviously not all decimals are going to be as easily converted, and probably you didn't know this ninth trick here to be able to give me a fraction. But there is a formula for you can find the sum of an infinite geometric series just like we did here without having to work it out every time. But there's some rules. Notice here, if we were thinking about what the common ratio would be, every time we're multiplying by 1/10, it goes back to what the converging diverging thing, and it's all about that ratio. So let's look at some rules here. Let's start with this. If the sum of an infinite series converges, remember that means it's going towards a specific value, like the last one was getting smaller and smaller every time, going towards 0. So if it converges, then you're going to be able to give me the sum of that sequence or series. But if it doesn't converge, then it just diverges, and you can't add that up, and you would never get the sum because it's just going to keep getting bigger, which is what diverges mean. And the nice thing is you don't have to actually actually work it out every time? You could, but there's just a lovely formula. This is a whole lot of formula chapter. And there's a really easy way to tell if your geometric series converges, and it's all about that common ratio. And so I'm just going to kind of give you this, and we'll talk about it. But it's all about whether that ratio is a fraction less than 1. This means if and only if. That's a little math lingo. So if you want to write that out, that's if and only if. I guess I could give you the sum. If you notice, this is very similar to the formula for a finite geometric series. You're just missing that top part. And the reason that top part is gone is if you take r to infinity, then that goes to 0 there. So it's just the first number divided by 1 minus r, which means you should be able to get me the answers pretty quickly on these. But the big thing is, in order to use this formula, your ratio has to be less than 1, the absolute value. Because if it's bigger than 1, your sequence is just going to keep growing. Okay? Questions about that? I got 2 more examples and we're done already. Can I go? Not go? Yes, go. And again, the big thing is, the formula you don't even have to memorize. I'm going to either give it to you or let you write it yourself. You got to know when to use it, and you got to know the rules. It says determine if the infinite geometric series converges, which means you need to know what R is. And then if it converges, then you can find the sum using that formula. So I'm going to give you 2 different examples here. One where they actually just write out the different terms, which means you got to tell me what R is, and then the other one over here is going to be written with the formula, and we'll figure out what R is. You got to say what's happening. R is what am I doing to get from here to here, to get from here to here, to get from here to here. So you got to be able to do some arithmetic there, some math, and say what do I multiply 1 over 48 by to get 1 over 16? Or maybe easier to think about is what do I multiply 1 over 16 by to get 3 over 16? If you don't know, you can always set up a problem. You could say 1 over 48 times what R equals 1 over 16. Always works if you're not sure. That's exactly what you're asking yourself to do. How would you solve that for R if you didn't know the answer? I could multiply by 48. And I would get 48 over 16. Or 3. What do I multiply 1 over 16 to by 3 over 16? It's just 3. When you multiply fractions, you just take top times top, bottom times bottom. 3 over 48 and 1 over 16. 1 over 16 times 3 is 3 over 16. Multiply by 3 again, you get 9 over 16. You got to be able to do this, or you can't use the formula. Is this going to converge? What's the rule for converging? The absolute value of r has to be less than 1. Is this going to converge? No, 3 is not less than 1. That means that we're just going to keep getting bigger numbers, and these are each bigger. 1/16, right? Yes, those are each bigger. 3/16, 9/16. 9/16 is over a half now. These are all under a half. Which means that, does this converge? No. Which means I can't find the sum if it doesn't converge. It's just going to keep getting bigger. It's going to go to infinity. This one they give to you in summation notation. They say the sum from 0 to infinity of 16 times 1/2 to the n power. One thing to notice on this one before we just jump into the problem is most of the time what we've done, the bottom number started with 1, and I think someone asked yesterday, is it always going to start at 1? And I said usually, but it doesn't have to. Sometimes it starts at 0, but you would still do this the same way. If you were going to work this out, this is your starting number at the bottom, so you would start with 0 right here, and your first term would be 16 times 1/2 to the 0, which would just be 16. Do you agree with that? Because it starts with 0, not with 1. Really important to pay attention to the notation. Maybe you can tell what we're doing every time, but maybe let's just work out a couple of them. What if I plugged in the next number? What if I plugged in 1 here? What would I get? Times 1/2 to the 1, or 16 times 1/2, 8. After you do two terms, you should be able to tell me what r is. We could keep going if you want. What is r in this? What am I multiplying by to go from 16 to 8? 1/2. And it's not a coincidence that this right here is our r value. Whatever you have to the power, if they give you the formula, should be your r value every time. But if you're not sure, just work it out and you can do that. So if r is 1/2, is that one going to converge? Yes, because 1/2 is less than 1. So that means that this converges, which means that I can find that sum, that infinite sum. And I'm just going to use that formula. I'm going to take the first term over 1 minus r. And you shouldn't have to give me decimals on these. Like, these should work out. Give me a fraction if it's a fractional answer. But you should be able to give me these answers here. So on this one, what was my first term? 16 over 1 minus 1/2, which is just 16 divided by 1/2. You can do that on your calculator, but dividing by 1/2 is the same as multiplying by 2. So I think that we get 16 times 2, or this would have a sum of 32. And it's not estimating, like we're not rounding it. Like that exact sum, if you add it up forever, would be 32. Isn't that kind of crazy? You never thought you could add something to infinity. Now you can. Tomorrow is our last section. Tomorrow the section is called proof by induction. So you need to come in here ready to do some thinking tomorrow and ready to really work through some problems. Tomorrow was a tough section, but you got to come in ready to focus and pay lots of attention, because if you zone off for 2 minutes, you're going to be lost. So really come in here tomorrow ready to learn. Tomorrow is our last section of the whole semester. This is 9-5 day 2. It's not that bad. You actually have some time to work. If you still have other questions over yesterday's homework or old homework, it'd be a great time to ask me that as well, since you have some time in here. But again, come in here ready to learn tomorrow. Tomorrow's a tough section, but it is something that you're requires learning in pre-calculus is doing proof by induction. So. It means it, yes, right. If R is less than 1, that means it's going to complete. But it means you can actually get a sum out of it. Like on this one, it's just going to keep getting bigger. And so like if you try to add up something else that keeps getting bigger, you're not going to ever get something that's like, the idea is this is eventually going to get so small it's going to be 0. And that's why it converts. Does that make sense? That's what conversions mean. Like it goes to. Right. Stop recording.